Hi, I'm Dan. You might have seen me during the keynote yesterday. I've been working on the Node Manager's Closure backend since I got to Puppet 9 months ago. And I'm going to talk to you today in detail about its domain model and how to use it. So my talk comes in 3 main thrusts. In the first part, I'll explain the node group hierarchy, what a node group is, and how they interact with each other through inheritance. In the second part, I'm going to talk about what happens when a node checks in and asks for its catalog. And then in the third part, I'm going to talk a little bit about the role-based access control permissions that we've added to the manager and how you can use those to segment your infrastructure up by responsibility. So the node manager's node hierarchy is a single inheritance hierarchy with a known global root called the default group that matches all nodes. And then nodes can inherit from nodes further up in the hierarchy by setting them as their parent. Now, what attributes does a node group have? Here's a list of an example in a JSON-like structure of the most important properties of a node group. There are the classification-related fields. Now, these are the things that are going to come through the ENC interface to the master. These are the outputs of the manager. It sets an environment. It sets the values of top-level variables for the node. And it adds class associations and sets specific values for the class parameters. Now, we validate the classes and the class parameters that you set in your group by looking at the classes that exist in the master in the environment that the group sets. So the node manager is fully environment aware. No longer do you have the problem where the console thinks there's just one class that lives in multiple environments and sort of gloms all the interfaces together. We can tell the difference between 2 versions of the same class that live in different environments and have different interfaces in each environment. And finally, we have the inherited fields. Now, these are the fields that sort of fall down to the children when you set an inheritance relation. And the concrete values, that is, the specific values of top-level variables and class parameters, can be overridden. So I'm going to go into a little more detail now about how exactly inheritance between groups works. So at the simplest level, let's say we have a space dwellings class, or space dwellings group that describes all of our nodes that are going to be in space. And now each one of these has to have a pressure hull. And then we're going to inherit from that group to describe our spaceships, which all have a warp drive. And when we look at the inherited form of the lower group, the spaceships group, the class that's set in the parent sort of drops down and slots in right beside the warp drive class. They're merged together. Now, if we have the space dwellings class set a parameter for the pressure hull class, say that all of our nodes in space are going to have 3 layers of pressure hulls for redundancy. And then in the spaceships class, we set a different parameter. That is, all of our spaceships are going to have 40 decks. Then when we look at the inherited view of the spaceships node, the spaceships group, the parameter that is set up in the parent just drops in beside the other parameter that we set in the lower group. The parameters are merged together if they're disjoint. And finally, we can override the specific values of class parameters. So let's say that we had the spaceships groups set 40 decks in our pressure hull. And then we had a more specific group, stealth spaceships. And these spaceships are going to be a little smaller to not have as much of a sensor signature. And so we say that they only have 10 decks each. Now, because these are both talking about the same specific class parameter value, the lower one is going to override the one that it inherits from its parent. And then top-level variables work in much the same way as specific class parameters, except they don't have, a parent class association. If we set a specific value in a parent, and then override that value in a child, then the overridden value in the child is the one that is used. And if a value is not specified for a top-level variable that the parent sets, then it just falls down when we inherit the values from the parent. Now, one slightly tricky thing is that rules are also inherited. So in the spaceships group, we're going to put nodes in there that have a pressurized hull. And then in our warp spaceships, we're going to specify that they have to have a warp drive engine. So this rule syntax should look pretty familiar to you if you've used PuppetDB's query API. And in fact, they're designed to be compatible, but I'm not going to go into the specifics of how they're formed. Now, looking at just this, you might be concerned, what if we had some kind of warp dune buggy? This doesn't have a pressure hull, but it has a warp engine. Is it going to get put in the warp spaceships group? And the inheritance of rules ensures that it won't. When we inherit our ancestors' rules, we put all of them in a conjunction with our own rule. So in order to match the group, you have to match all of the ancestors of that group up to the root group, which matches everything. An equivalent and probably more useful way to think about rule inheritance is that nodes are inherited down, and at each step, a group performs a filtering operation on the nodes of its parent. So each group's nodes is necessarily a subset of the nodes that its parent group refers to. We'll have all of our group in the default node group, and then we'll filter that down to talk about our spaceships, which is necessarily a subset, and again, we filter that down to define our warp spaceships. And at each step, it's always a subset of the nodes of its parent. Now, I've said that this is a single inheritance hierarchy, so you might be a little concerned about this example hierarchy that I have here. Because the nodes filter from the parent nodes, are you telling me that I can't have monitoring on my web servers? Or I can't have web servers that are Debian boxes? And the solution to this is that while node groups are single inheritance, a node is not restricted to matching only one node group. A node can match multiple node groups. So this introduces a complication of what exactly happens when my node checks in and asks for a catalog. It's not as simple as finding which group that the node matches, pulling down the inherited values, and then just sending that out. There's a little more that's going on. So there's a 4-step composition process that happens when a node checks in to the master and sends its facts, and then the master asks the manager to produce a classification. So the first thing we do is we look at the hierarchy and see all of the node groups that node matches. Now, because all nodes will match the default, you are not allowed to edit the default group's rule. And if a node matches a group, it matches all of its parents up through the default, then we necessarily have a matching subtree. So after we find this matching subtree, we go in and we find the leaves of that subtree. That is where the matching stops. And this is not necessarily the group that has no child, because we could have children that node doesn't match, but they're the bottoms of the matching subtrees. After we've found those leaves, then we go ahead and we add all the inherited values that those leaves get from all of their ancestors all the way up through the default group. There's not going to be any conflicts here because inheritance is the node manager's mechanism for disambiguating between the same parameter and the same top-level variable that have different values. But once we have the inherited view of each of our node groups, we have to attempt to merge them or compose them into a single classification result. And we can only do this composition successfully if there are no conflicts between the fully inherited forms of our leaf groups. So here's an example of a composition conflict that you might find. If there's no inheritance relationship between spaceships and stealth spaceships, and they both set different values for the same class parameter, then that's going to be a conflict. And when the node manager finds a conflict during this composition process, it sends back a 500 result to the master, and the master will fail to compile the catalog, so the node will use its last cache catalog if possible. If the node manager is unable to understand what you've told it, it'll just blow up instead of trying to find some resolution without further input from you. So let's look at a more realistic example of a classification composition conflict that you might see. So let's say we have a node group that describes the configuration for all of our Tomcat servers. And then we've created two further children that specify the configuration specifically for the red app and another one for the blue app. Now in production, these are normally deployed separately. So the red app node group can set the Tomcat threads to 4, and the blue app node group can set the Tomcat threads to 3. And as long as these aren't applied to the same node, then we're going to be fine. But let's say that during testing, because we don't have very many testing machines, we put both of these on the same testing node. Then we run into a conflict between the different parameter values for the threads parameter of the Tomcat class. Now, the way to resolve this, or one way to resolve this, is through inheritance. Since we don't have an inheritance relation that allows us to disambiguate, we're going to create a child group of, let's say, red app, and that's only going to apply to testing. And you would edit the rule of this group to only match the testing node and not change the value for any of your production servers. And then this would set the value of that class parameter to agree with the blue app one. And when that node is classified into these two groups, then the values agree and there are no composition conflicts. Now, even more problematic than class parameters is probably going to be environment. Since environment is a primitive value, it's either one environment or the other, there's no way to merge them. If your node is classified into multiple groups that specify different environments, you're going to get a conflict. And now there's one field of a group that I haven't told you about yet, and that's the environment trumps. And this is added after feedback from our customer service department to allow you to set environment in most places of your node hierarchy only for validation that those classes and interfaces exist, and then have a branch of your node group hierarchy whose only purpose is to determine definitively what environment each node lives in. So if a node is classified into multiple node groups and none of them have this environment trumps flag set, then and they have different environments, then there's going to be a conflict. But if only one of them has the trump flag, then that one will win. We'll set that environment and send it back to the master. We don't get a strong validation here, but we'll send it to the master. If the master is okay with it, if it agrees that the classes and the class parameters that you've assigned do exist in the environment that has been overridden, everything will work. If not, you'll get a catalog compilation error, and you'll have to go in and adjust the environment for one of them. Now, we recognize that this is probably going to be the most difficult part of using the node manager. And so we have a route that allows you to see exactly what's happening at each step of the composition conflict. If you hit this endpoint on the classifier's API, and you, in the body of what's going to be a post request, submit the facts that you want to test out, then you're going to get back a response that has these fields. The matches is going to correspond to the first step of the composition process. It's just going to have each group that the node match without any inherited values added. And then the leaves is going to be the leaves of that matching tree subset, where the matching stops. And then the inherited field is going to show you what each of those leaves look like after we've added the inherited values. And then finally, you're going to get one of these two other keys. That's either the merged one, if there were no conflicts and the composition process was successful. If there are conflicts, then you'll get a value in the conflicts key. And the value is going to look like a node group, except instead of specific parameters or specific values at each place where you get a conflict, we're going to have an array of values or an array of maps that describe not only what the value is, but which inherited leaf it came from, and if that value was defined in an ancestor of that inherited leaf, what ancestor of that leaf it actually came from. And so this allows you to easily distinguish between, oh, I set the wrong value in this leaf versus, oh, I set the wrong value in an ancestor of this leaf. But the overriding rule that we've come up with so far is that you should keep the functionality of your group separate. This will minimize the chance that they're going to care about the same class and that they're going to set conflicting values for class parameters. If you're familiar with roles and profiles, what we think is that each group should match to a profile. It should define some functionally isolated bit of functionality. And then the role, instead of being a concrete class, is just whatever groups you happen to match in the hierarchy. So finally, I'm going to talk about the role-based access control permissions that we have in the node manager. Now, the first thing to know about the permissions is, like many other things in the manager, permissions are going to inherit downward through the hierarchy. So if you have a permission on one group, then you'll have it for all of its immediate children. And if you have it on a group, then you also have it for all its grandchildren, and so on and so forth. The permission defines a subtree at a specific node under which you have that permission for everything in that subtree. And consequently, if you have a permission on the root group, you necessarily have it everywhere else. So these are the permissions that we have so far. There's view, edit classification, set environment, edit child rules, create, delete, and edit children. I'm not going to go into exactly what each of these means on their own. Instead, I'm going to describe some of the use cases that we have thought about and created the permissions around. So the view permission allows you to have hidden values that some members of your organization can see and some can't. When we have a hidden value in a group that is invisible to the current user, and then the user looks at the inherited form of the group, then we're going to redact all of the concrete class parameter values and top-level variable values that you set up in the hidden group. They're still going to be able to probably tell that the group exists if they can see any of its children, because there will be a parent link there. It's more about hiding the values of the classification values that the group sets, rather than hiding that the group exists at all. Another use case is just creating a group, setting the rules of that group, and then allowing some of your team members to change the functionality of that group. That is, to change the top-level variables, to change the classes, and change the class parameters. You can be sure that they're only going to be able to change the functionality of the nodes that are in this group, because they're not allowed to edit the rule. That's a separate permission from being able to edit the classification. They can also edit the name and the description field, which I haven't talked about, which is an optional group that mainly just helps them explain what the group is for. They can't change the parent link, they can't change the rule, and they can't change the environment. So you can lock down the environment, you can lock down the nodes, and they can't get around what nodes that they can inherit by changing the parent link. Another thing you might want to do is set up a prescribed subtree for some members of your team. So you can create a container group for your Suite app and all of the web server functionality that you want to have for it. And you can give some of your team members the view permission, the edit classification permission, and the edit child rules permission. Now, the edit child rules permission has somewhat of an odd name, because why do you need to specify child rules? Didn't you say that all permissions inherit downward? And the difference between this and the other permissions is that the permission is not about the group that you're granted it on. The permission is about being able to do it on the children. And so the functionality of this class of permissions is to allow members of your team to move nodes between your production web servers group and the staging web servers group. But because they can't edit the rule on the container group that is at the top of the subtree, they'll never be able to affect more nodes than what that container group can affect. And finally, you might want to give members of your team access to basically do whatever they want within a subtree of the manager. So you can give them view, edit classification, and the ability to create, delete, and edit children for this group. And so that allows them to create new groups that are children of this group, and allows them to delete groups that they've created, or maybe that you've created to help start them out. But because they still don't have permission to edit the rules on this container group, again, the nodes in this subtree are restricted. So you can give them a lot of freedom to organize their functionality in a way that they think is useful to them, but without breaking out of sort of the containment of the nodes that you've set up. They can even go so far as to create grandchildren, again, because these permissions inherit downward. And there is actually no edit rules permission in this, because the ability to edit rules everywhere is accomplished by having edit child rules on the root group, since you're not even allowed to edit the root group's rules. So what we've hoped is that we've built something like Legos. We have this concept of a node group, and we have this inheritance between the groups. The way that the node groups fit together piece by piece is always the same, but the overall shape of your hierarchy can take many different forms. We hope that you'll figure out a way to organize your hierarchy that makes sense not only for the functionality that you want to implement in it, but for the structure of your team and how you want to divvy up responsibility for different parts of your infrastructure between different parts of your organization. So I ran even faster than I did during practice. This is all that I have to talk about. And if anyone wants to ask questions about this, please do. Yeah.
One thing that has been clear to me through this is we talked, you saw yesterday kind of this Node, we had the first one of the apps and things like that. Are we, are we open source Puppet master, Puppet server administrator going to have this kind of functionality as well? Are the apps going to
So, as far as I know, the plan is for the Puppet apps to be PE-only features. So this is going to be coming out in PE 3.4, and there's no plans to have it be open source in the plannable future.
Although some of it can be done through dashboard, right? To a certain extent.
Yeah, well, I'm not familiar with the open source dashboard, but this does just use the ENC interface of Puppet. So there's no privileged access to this above what a normal ENC can do. Mm-hmm.
In our infrastructure, we utilize the concept of environment as our Puppet life cycle as opposed to our node segregation. How would this operate within that? So we often use the ability to run against a separate environment live so we can validate our manifest that we just developed.
So you use a workflow where you specify the environment on the agent, and then you run a test run to see how it works out. So we did add a special environment value in here called agent specified. And if you set a node group to have that environment, then the terminus and the master that receives the classification output from the classifier is going to omit specifying the environment. And so much of the validation that it does will go away, but it does allow you to set up a group where you can have a specific node that you want to test new environments out on without having to go in and change the environment in the manager interface each time. Exactly. So the data is stored in a Postgres database.
Can you explain the Trump feature some more and how it relates to what's conflict resolution?
So the trumps feature is only for environment, and it allows you to have a section of your hierarchy that is absolutely definitive about environment, and not have to worry as much about having the environments agree in all of the other groups that a node matches into. And if you know who Reed Vandewald is, he's the one who advocated for this feature. And so if you want to talk more about the kinds of situations that he has in mind for using this feature, he would be a good person to talk to. Yeah, back. So the external node classifier's output environment trumps whatever is set on the agent side, either through a command line variable or in your agent's puppet.conf. Mm-hmm.
Classification, is that run every time the node checks in?
Yes. So you can do things like set a rule in your group to add extra monitoring to nodes that have been up for less than 7 days. And then as it checks in, and then it checks in on the 8th day, and that fact changes, and it falls out of that group. And any nodes that you spin up are going to be in that group automatically. Any further questions? All right. Well, I hope this wasn't too much of a highly compressed info dump. If you think of any questions later, I'll be wandering around for the rest of the day. So just flag me down. I'd be happy to talk. Thank you very much.